Oh, actually, there's no camera off button over here. How do I turn on the camera? I need camera capture. So I was thinking on let me just create one. Damn, this is so weird though. I need a better camera blocker. Okay, let me share my screen. Let me share this window. Leetcode. Hmm. Sign in. Google. Sign in. Okay, so we are logged in. Explore. Maybe. Top interview questions. Well, top 150. Interview. Starting with the top 150 interview questions. 15 questions a day. 10 days to go. Let me share my screen. Top 150 interview questions. A fresh start. 10 days. 15 days. 10 questions a day. We're gonna start from easy, then medium, then there are hard questions coming up. So you're solving the first question. I mean, it's 88 in the entire lead code, but for top 150, it is the first question. Merge sorted array. So yeah, there are two numbers, and we just need to merge them and put it in the first array itself without using any space. I mean, with using constant space, and yeah, that's it. Simple one. So what we're gonna do is use the last element, compare them, and assign it to the last, like from the decreasing order, not the increasing one. So yeah, I mean, we compare them and assign it and decrease the pointers. So we have kept one pointer for A, J pointer for B, K pointer for the merged array. So let's try to run this. Alright. Edge cases. J is Interesting. If n equal to 0, return a. What does this do? This is m. This is n. My bad. Alrighty, we are ready to submit. First question, first attempt. Let's go. Woohoo, accepted. We have a bad username. Settings. How to change my name? Sharp Labs. I mean, okay. Yeah, alright, let's go back. First question done. More to go. Next. Remove element. Remove all occurrences of val in nums in place. The order of the elements must not be changed. Then return the elements number of elements in nums which are not equal to val. Alright. So if you're trying to remove 3, so nums will be just 2 and 2, and the out will be 2, because those are the remaining elements, that is 2 and 2. So if there are 5, so there are 5 elements remaining. Okay. So what are we gonna do? Um, I pointer and a j pointer. Now if I pointer is equal to val, then skip that pointer, or else a of I is equal to j of I. What I mean is, for example here, I and j both are at 0th position. I mean 0 indexed. So a of I is not equal to val, that is 2. So a of I is equal to a of j. So we're just gonna keep there itself. But let's say a of I is equal to val. Now in that case we're gonna skip j. We're gonna keep the j pointer here itself and move the I pointer to the next one. So here also we're gonna move it to the next one. Now in this case, a of I is not equal to val. So in a of j we'll put a of I. So that is 3 will go here. I mean essentially you got it right. I mean if you didn't, otherwise I'm gonna show it to you now. Int n is equal to a dot size. Always. Int I is equal to 0, j is equal to 0, while I is less than n, and j is also less than n. But j will also always be behind I, so it doesn't matter. Now if a of I is equal to is not equal to val, we simply assign a of j is equal to a of I and move on. We'll do j plus plus. Else if a of I is equal to val, we will not do j plus plus. We will simply do I plus plus always. So I plus plus will always happen incrementally. But we also need a counter so that int c is equal to 0, so that we can return it. Simply that's it. I mean we'll just do c plus plus, language c plus plus, return c. Okay, we're doing c plus plus, but we're doing c actually. Name job. Wrong answer. This was right. Why is this wrong? Maybe changed. I don't want to change it. Interesting. Alright, we're just gonna see out every time we got A of J. What? Ah, J plus. No mind. 01304. That's right. But why is not the count increasing? Let's say C. We should not return C. We should return n minus 2, obviously. Remaining elements. Comment, comment. But we should not leave comments in our production code, right? Obviously. Woohoo! Beats 100%. 0 milliseconds. Like, it doesn't say, take microsecond as well. I mean, but the measurement maximum is in milliseconds, so can't say. Fun fact is, our CPUs can do 10 to the power of 9 operations per second. If I'm right. Hmm. Need to check. Number of operations CPU in 1 second. Hmm. So the minimum is 10 power 9. 1 gigahertz is a very standard range like CPUs can deal with these days. Alright, coming back. Yeah, we're back. So two questions done. Next, remove duplicates from sorted array. Alright. So we need to make the entire array unique. One thing is you just make a hash map of it or a set, an ordered set of it. Just keep adding elements. The element is not present, then it will be flushed out. But if the element, I mean, it will be added, or if it is already present, then it will be flushed out. But that will take a lot of space. And what do I need to return back? Unique elements, number of unique elements, obviously. Image quickly does to the unordered set thing s a for auto That's a s dot insert into set C plus plus. Let me just do it. That's insert. Yeah, simply insert x. What's the order? Set to vector C plus plus. Set to vector C plus plus inline. We can do assign. We can do copy. We'll do a dot assign s dot begin, comma s dot end. Return s dot size. Yeah, let's see. I mean, it's not. It's just set a by. Yeah, but this is slow. We can make it faster. Here, need to go here. Let's do it inline. Next submission. N equal to a dot size, obviously every time. Two pointers again. While I less than n. Now if see if I is equal to 1, we're gonna start with 0. Alright, we're gonna check the next element. The next element is the same. We're gonna keep the j pointer there itself. If the next element is different, we're gonna move the next j pointer. Sort? Alright. So we're gonna check till the last but one element because yeah. Now if a of I is equal to a of I plus 1, what we're gonna do is we're gonna keep the j pointer there itself when we want C plus plus. No one likes C, I guess, these days. Now else what we're gonna do is we're just gonna do a of j is equal to a of I j plus plus I plus plus. Is there some plus one shenanigans which I'm not able to find? Return, bro, return. N minus C. Yeah, it copied the same number here. Not the next number. So what you're gonna do is we're gonna paste I plus 1 here. It's not equal. Or we're gonna start from 1. We're gonna check it. from till the end if a of I is equal to a of I minus 1. And we have already simulated. Why am I even doing this? Why am I even doing this? Okay, this is also gonna start from 1 because if there's only one element, it's always unique. Now, if it weren't equal, then I'm gonna keep j in place. But if it was equal, then I'm not gonna increase j. Alright, done. Simple, simple, very simple. Submit. Let's just take the corner cases. If n equal to 1, I equal to 1, c 0, n minus c. Done. Woohoo, 100%. So, what is the crux of this problem? So, essential, the core solution to this is to do it in place and try to overlap the elements which are not required and try to paste the further elements on the unwanted elements of the array by comparing it with two pointers and moving it like this, one after the other. Removing duplicates for sorted array, next level. Let's go for it. So the twist is that we need to do it in place such that each unique element appears at most twice. A little bit twist. Relative order should be kept same in place, so the dirty hash map things are invalid. So we need to return k, final number of slots. All right. No allocating more memory. Oh, one extra space. I'm gonna explain O n square in means time. Let's just think about this question now. So one appears thrice, so we need to remove it once. Okay, remove. Okay, we're gonna have two pointers, and we'll have a counter as well, number of times that it has occurred. As it is an increasing, let's say we are at j is I equal to 1. I mean, because one is always unique. Now, if I is equal to a of j and the counter is 1, we're gonna increase the counter to 2. The two elements are done, and still keep a of j is equal to a of I. Now, if anyone knowing next, the counter is already 2, and a of I is equal to a of I minus 1. The counter becomes 3. So it means it is invalid. So we're not going to increase j. I mean, we're not going to do a of j is equal to a of I. And we're going to skip this element then. And then move further. Now, when we have skipped it, a of I is not equal to a of I minus 1 before even placing it here. To explain you, see, this, This is the initial array. Now we're gonna check these three, and both of them are equal. I mean, in this situation, a of I is, we have skipped this element, and we're gonna not gonna save it, but nothing has overridden this yet. Now when we're gonna check a of I is not equal to a of I minus one, we wanna paste a of j here. So we're gonna paste this here. We're gonna paste this here. I mean, these are just gonna be the same. But next time when we're gonna checking it, a of I has moved here. So a of I is equal to a of I minus one, and the counter becomes one. Okay, so this triplet is not a problem. Hmm. Then let's hope that works. Hmm. I We're gonna start with one, right? Because one element can never be unique. C is zero, a counter, and the temp counter we need, we'll call it T, while I is less than n. So now, if a of I is not equal to a of I minus 1, that's a simpler case. Let's just do that. So we're gonna just put a of j is equal to a of I, and we're gonna do j plus plus. Now else, it could be equal. So now when it is equal, if temp is equal to 1, so it means we have found the pair once already, and we are finding it second time. So we're gonna skip j. So we're gonna do c plus plus. So we're gonna skip something, right? So we're skipping the third one. Now if temp, and we're gonna reset the temp to 0. No, we're gonna not reset it. We're gonna do temp plus plus itself, greater than equal to 1. And if it's not equal, then reset the temp again. Else we're gonna do t plus plus anyway, and normal routine. N minus c. Okay, run. I don't know what's happening, but yeah, let's see. Okay, accepted. First run. Good hands. Good hands. Submit. No. All right, accepted. But we're still over. All right. First, let's go on the crux. Removing duplicates from sorted array 2. The crux of this problem is you have two pointers I and j, where I is reading and j is just following back, and you're pasting the elements of I on j, and thus overriding the elements which are not required, and keeping a counter of c that are the duplicate elements. Now the change is that you have a temporary variable that counts the number of times that you have gotten the duplicates. And if the temporary variable is about 2, I mean you have found it 2 times, then you're going to discard the elements after that. So that's the whole crux of it. We found an accepted solution, but there are people who have done it much more faster. Let's see their solution. Hmm. For each number in nums, if the index right is less than 2 and num is greater than numbers of, oh, it's ascending. So if it's greater than 2 indexes before, You're just gonna put n, that is the current element, in the index, that is j. Let's say this was rj. So till j is 2, we're just gonna put j till, or else we're gonna check two elements before j. I mean, two elements of, yeah, nums of j. Check the current element is equal to it. What? Okay. Hmm. Okay. But don't you find the problem of 222 in this? I mean, you are pasted 2 before and you have done I plus plus. Hmm. Okay, but this is the real array. I mean, that is one element always behind n, let's say in our first scenario. Okay, this also works. All similar versions with lesser constants, but yeah, this is the same time complexity, so not a problem. Same range. Majority element. This is a very fun and intuitive problem, and it has a very fun solution as well. So essentially, I've given an array of numbers. You need to find a number which appears more than n minus 2 times, n by 2 times. Let me straight go to the solution because I know it. So we assume that the first element is always the majority element. Probability, right? So let's say 3 is the majority element. Now we're gonna count the number of times that 3 occurs. So if 3 occurs once, now then let's say the majority element doesn't occur. So we're gonna scratch this out together. Because even if we are scratching all the non-majority elements with the majority elements, they're gonna still be more majority elements. So even if we scratch these out, there is still another majority. Only the majority elements will be remaining, essentially. So using the counters of 3, we can scratch out the non-majority elements. And even after that, if the majority element survives, then yeah, that's the majority element. Okay, that's gonna do a n is equal to a dot size. Always, let's say answer is our majority element, that is a of 0. Okay, n is greater than or equal to 1, so there will always be the 0th element, right? Now, pointer, I need a pointer. While I less than n, okay, the first one is already answered. So we'll start from 1 the index. If a of I is equal to the majority element, we're gonna do C plus plus, that is the counter. Else, what we're gonna do C minus. I mean, if we're gonna check if C greater than 0, we're gonna do C minus minus. If it is equal to 0, so we have found a new majority element. Answer is this element. This element is this and C plus plus. Because C is 0, now C goes to 1. So initially C also starts with 1 because the first element is 1. Now we're gonna return the answer. Yeah, I did some crack overflow. Ah, I plus plus is not there. Okay, I accepted. Submit. Okay, accepted. Top, 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 top. This is fine. Okay, majority element. The crux of this problem was to find that catch that you the non-majority elements can cancel out the majority elements, and still there will be more elements remaining. I need to find that. So again, it's the counters play. Like keep a counter and have a count and subtract it from the counter. That's all. Simple. Hmm. Given an integer array, nums, we're gonna change it to a obviously. Rotate the array to right by k steps, where k is non-negative. K can be zero as well. How many questions have we done? One, two, three, four, five, six, seven, eight, nine, 10. Okay. Just give me a moment to think about it. Man. Okay. Back to our overriding IJ technique. One, two, three, four, five, six, seven. Okay. Okay, is three. So the thing is, one move to the right, meaning we need to put one over here, two over here, three over here, four over here. Then these elements will be lost somewhere. Where do we put it? Let's say we swap them, okay? We have only this much space. We need to put all our brains to wherever they are. So in our resulting problem, one should go in the place of four. So we're gonna swap four, two, three, one, five, six, seven. Okay. So now the second one should go after one. So it's gonna be four, five, three, one, two, six, seven. 4 and 5 will stay the same. Now 3 is gonna be with 6. 6, 1, 2, 3, 7. But we have already conquered the place of 4. Let's say that it was a very long array. What about it then? There are more elements to swap, but we have already conquered the, like, basically messed up the first three ones. Let's do it from the back. 7 doesn't have space to go out because there's nothing on the right. 6 doesn't have has only one place. 5 has only two places. 4 has three places to go, and this is the last place for 4 to go. So we're gonna start with n minus k element minus one element till zeroth element and keep swapping. Okay, let's see what happens. Say first time 2, 3 stay the same. 4 gets swapped with 7. So 5 and 6 are here and 4 is here. And say 1, 1, 2, 3 gets swapped with 6. So 6, 7, 5, and 4. Okay, sorry. 1, 2 gets swapped with 5, 6, 7, 2, 3, and 4. Now there's no problem swapping 1 with 7 because 7 is already in the wrong position. So 7, 5, 6, 1, 2, 3, 4. So now what has happened is we have swapped 1 to 4 three times to the right. K times k elements or steps to the right. In that process, n minus k minus 1 to n minus 1 elements have been swapped left. Multiple times actually. I mean, k has been swapped two times. I mean, 7 has been swapped two times to the left. 5 and 6 has been swapped one time to the left. K times left. So now we need to move them to the right position. Now n, okay, let's say n minus 1. So this was the position of 6. 6 got moved k times to the left. Hmm. So it means it got n minus k times to the right. So what did it actually happen? Like 1, 2, 3, 4. 4 times to the right. That is 7 minus 3 equal to 4. That is right. But it had to only go 3 times to the right and not 4 times. So it has gone one time extra to the right. So to compensate it, it should go one time to the left. Yeah. So that means n minus 1, which is equal to 7 minus 1 times to the right. But all these positions are already in the right positions. Only these three positions are in the wrong position. So this is equal to 6 times to the right. But n is 3 over here. So 3 minus 1, two positions to the right. That became n minus k minus 1. So n minus k times to the right is 4 times is the reality that it has moved. So to compensate it, it needs to move n minus k to the right हो गया ना. So n minus k. So that is 7 k minus n minus k. Okay, that is equal to 2k minus n to the left, which is equal to, now the k has also n has also changed. One time to the left, but there are only three elements to work with. So the n right now is n minus k. That is 7 minus 3. Only k basically, right? Yeah, k is the reminder always, because only first three elements will be fucked up. Rest all elements will be fine. So k minus of 2k minus n, which is equal to k, what the n minus k. There is 2. No, 4 times to the right is equal to 1 time to the left. How did we come up with this number? If something went 1 time to the right, it is n minus k times to the left. But we actually intended to go n minus k times, we went to the right, but we need to go only k times to the right. So the remainder is n minus k times to the right. N minus k times to the right is remaining. The just give me an extra array. Problem so easy then. No, these three elements will keep getting swapped, 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 and each time they're getting swapped, they're moving, moving, moving. And if it is not equal number of times that they're moving, let's say this is a bit easier. And I'm just gonna save these. So these three numbers we're gonna sacrifice. 1, 2, 3, 4, 5, 6 is gonna swap with 9, 7, and 8, and then it is 6. So two steps further, it's gonna look something like 1, 2, 3. It will be 7, 8, 9, and then it will be 4, 5, 6. Two steps. K is still 3, okay? Now we're gonna do 7, 8, 9. We're gonna do 1, 2, 3, 4, 5, 6. And this is the right position. So the 7, 8, 9 didn't get mixed up, is the point. No, 7, 5, 6, 7 came here, but they came in the wrong positions. So they just need to go one position to the left now to solve the problem. And that is found by the remainder of number of elements divided by k. Hmm. Let's say k was 4 in this case. Then the remainder is 1. We need a remainder of 2 somehow. Let's say 10. Now the remainder of 4 is 2. Let's say we're gonna do 3, 4, 5, 6 to that place. 1, 2. So 3 is gonna be swapped with 7, 8, 9, 10. Then we're gonna do 3, 4, 5, 6. 4 steps. K is equal to 4, N is equal to 10. Okay. Now 1 and 2 is gonna be swapped with 9 and 10. 9, 9, 10, 7, 8, 1, 2, 3, 4, 5, 6. 2 steps. Okay. What happened is it is incorrect by 2 steps to the left and not to the right. Hmm. So we're gonna 2 steps to the left. Uh, Now how are you gonna know if the left is right or wrong? We need a mirror function of the entire right thing. Instead of that, we can just keep doing the right, right, right multiple times until we find the solution right. No, you're gonna do void right vector int ampersand a int k. How many times to the right, starting, ending. I'm gonna do in out. Okay. I mean, we're specifying from which element to which element we're gonna rotate and how many times are we gonna rotate. And what are we gonna return? We're gonna return until a divided by k is divisible. Till then, we need to keep doing it. But what is the next k? The right position of 7 was 1 and 2, two positions to the right. N percentage k, that is 2. And then you do k minus n percentage k. Okay. Hmm. So, how do we move it to the right? Let's say in the first case, we're gonna do right of a comma k comma 0 comma a dot size. So we're gonna do I is equal to n minus k minus 1. We're gonna start from there. We're gonna keep j at n minus 1. Keep tick 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 swapping swapping swapping. We need a swap meter called t temporary variable until we reach I equal to 0. Well, I is greater than or equal to in, n is here out. Int t is equal to a of j, a of j, j is equal to a of I is equal to t. We have successfully swapped. Let's return an int. Okay. Now what are we gonna return is the remaining swaps required for right. And the remaining swaps are out minus in percentage k. Yeah. Now we're gonna do while is not equal to 0. Int remaining, how many rotations are remaining? Okay. While remaining is not equal to 0, we need to again do a write from a for how many times? Remaining times. And it will be from 0 till k. Am I right? 1, 2, 2 times to the right. That is 7% is the n minus k. N minus the remaining one. And remaining is equal to this. This is gonna run it somehow. Crashing, crashing, while loops crashing.